Hello, Kuldeep.
Hello, sir.
Yeah. So, thanks for joining. So, do you have any idea about the others?
सर मैं एसएमएस कर देता हूँ उसे.
Okay. Harshavardhan has joined. When everyone else will join, then we can start our today's session. Okay, so as three of you joined, so we can start our session today. So, as you know, today, today is the first day of our session. So, I would like to know your background. So, can one by one each of you can introduce yourself? We can start with Kuldeep. So, Kuldeep, can you please come and introduce yourself along with your background?
Hello, sir.
Yes.
Uh, my name is Kuldeep Birazdar. I am from Maharashtra, Dharashiv district, Sramjeevi College of Pharmacy.
Okay. So, and your background is which degree are you doing right now?
Bachelor of Pharmacy,
Bachelor of
final year.
Bachelor of Pharmacy. Okay.
Yes.
Then we can go to Harshavardhan. Hello. R.S. Harshavardhan, are you there? Okay. Aditya has joined. So next we can go to Vikrant. Vikrant, can you please come and introduce yourself along with your background?
Sir, myself Gauri Vikrant Vikas.
Yes.
I'm from Maharashtra district, Dharashav district, Shivai Charitable Trust College of Pharmacy. My
Okay. So
background is Bachelor of Pharmacy final year.
okay, fine. Thank you. So next, Aditya,
Yes, sir.
can you introduce yourself?
Yes, sir. Hello, everyone. My name is Aditya Patil. I'm a final year B Pharmacy student from Sramjeevi College of Pharmacy, Umarga, Maharashtra.
Okay. So three of you are
Thank you.
pursuing Bachelor of Pharmacy degree, right?
Yes, sir.
Okay. Okay. So okay, and R.S. Harshavardhan, are you there? Or any problem you are facing with your mic and all? Okay. Probably some network issue will be there. Okay. Anyway, so so the course which we will start, that is Introduction to Biochemistry. So can any of you tell me or define what is biochemistry? What do you understand about biochemistry? Anyone? Okay, Aditya, you have raised your hand. You can go ahead.
Biochemistry is the chemistry of life and the life processes.
Hello. Aditya, you are saying something? Okay, so he has some network issue. Okay, no problem. So, anyone else? Vikrant or Guldeep? No, Aditya, you are not audible.
Biochemistry is study of the structure and composition
Mhm.
and chemical reactions.
Of biomolecules, right? Yeah. So, yeah. So, in this course, we will try to give you uh, just a basic information about biochemistry. Hope you will be interested in this course, and my request to everyone that this course is this all of the sessions are going to be interactive. So I request everyone to interact with me, and especially whenever you will have problem, then please stop me, and don't hesitate. Feel free to ask me your doubts wherever you will face problem. Okay, and and I will ask you some questions just to discuss with you during the course. So please feel free to participate in the conversations. Okay, so uh, then we are going to start our first session, which is protein structure and function. Okay, so protein is a biomolecule, as we know. So can anyone tell me what is protein, and what are the building blocks of protein? Anyone? Okay, so protein is a example of biomolecules, right? And it is made up of amino acids. So as we are going to start to discuss about the biochemistry, so first we will study about water. Water is also a molecule, and water is an widely used solvent, right? So the role of water is to hydrolyze, just to make a hydrogen bond along with the solute, so that the solute can be dissolved. For example, here this is your NaCl, Na plus and Cl minus. This gray color spheres are Na plus, and these blue color spheres are Cl minus. So this is your NaCl crystal lattice. So when you will dissolve NaCl in water, then what you observe, NaCl will be dissolved, right? So you can't see basically any trace of NaCl, right? So what happens? What is the science behind this? Water will come, and as water is itself a polar molecule, so water will make a electrostatic interaction with negative charge Cl minus and positive charge Na plus. Water has O and 2 hydrogen, where O is electronegative and H is electropositive, right? So now this positive part of this NaCl, which is Na plus, that will make ionic interaction with so Pranam has joined. Yeah. So when we dissolve NaCl salt in water, then this electronegative part of water, which is oxygen, that make ionic interaction with Na plus ion, right? That is called hydration of Na plus ion, and Cl minus ions are hydrated by water because water has two. Each water molecules has two hydrogen, right? They are electron deficient, so they will make ionic interaction with the negative charge Cl minus, right? So that's why Cl minus will be hydrated. That's why neither you can see Na plus nor you can see Cl minus. That's why when you dissolve salt in water, then you cannot see the NaCl, right? So that is the case when we dissolve an ionic uh, salt, which is NaCl. Then that's what happens with that salt, right? Now we will see what happens to an amphipathic molecule in aqueous solution. So what is amphipathic molecule, anyone? What do you mean by amphipathic molecule? Pranam, what do you mean by amphipathic molecule?
Yes, sir.
Huh. What do you mean by amphipathic molecule? First of
Sir,
all,
it have both
huh,
both hydrophilic and hydrophobic regions.
yes, very good, very good. So amphipathic molecule has both hydrophilic and hydrophobic part. That means polar and non-polar part.
Yes, sir.
Yeah. So can you give me any example of amphipathic molecule?
Cholesterol.
Cholesterol. Very good. Fatty acid. Right. So
Yes, sir.
yeah. So here we will see example of amphipathic molecule where we dissolve the amphipathic molecule in aqueous solution. So here we have dissolved this fatty acid, and this fatty acid has two parts. One is this hydrophilic head group, which has a which is the C terminus of a fatty acid, which has the C double O minus carboxylic acid group. So because of this minus charge, this uh, head group of fatty acid is polar, means hydrophilic, and the remaining portion is an aliphatic chain, right? So which is a alkyl group, and this alkyl group is hydrophobic. So it has both hydrophobic as well as hydrophilic portion. That's why it is amphipathic molecule. So when we uh, try to dissolve this amphipathic molecule in the water, then what will happen? Water is polar, right? Water has electron deficient hydrogen and electronegative oxygen. So what will happen? First of all, water will start becoming arranged in a highly ordered manner. So they will make hydrogen bond among themselves, right? So see these two water molecules, each of the water molecules are connected with each other by this hydrogen bond, right? So they will be very uh, in a ordered manner, right? And this amphipathic molecule, it has this hydrophilic head group. So this hydrophilic head group will face the water. Okay, so this hydrophilic head group will face the water so that it can make interaction with the polar water molecule. And this hydrophobic alkyl group, that will be buried inside, right? So that it should not has to face water, right? So this is called caging of this amphipathic molecule. Highly ordered water molecules from cages around the hydrophobic alkyl chains. They will not make interaction with the alkyl chain, right? But they will have interaction among themselves, right? And only this polar group will make interaction with water, right? So similarly, when we so this is for the one amphipathic molecule. So when we will dissolve, uh, you know, stock of amphipathic molecule, then it will have multiple amphipathic molecule. So these multiple molecules will do the same thing like this here, right? So each lipid molecule forces surrounding H2O molecules to become highly ordered. So these H2O molecules will be will be arranged in a ordered manner, right? In this shape. Now only lipid portion at the edge of the cluster force the ordering of water, and fewer H2O molecules are ordered and entropy is increased, right? So now what will happen if H2O, if any molecules will be arranged in an ordered manner, then entropy will be decreased. But when fewer H2O molecules will be ordered, then entropy will be increased, right? Because entropy is degree of freedom. And then multiple, when this multiple amphipathic molecule will come, then there will be no water, right? So initially what is happening when you were dissolving individual molecules, then beside every individual molecules there will be water, right? See, around this amphipathic molecule, this amphipathic molecule, and in right in the vicinity of these three amphipathic molecule there will be ordered manner of water. But when they will come to close together in a same solution, then they will interact each other by hydrophobic interaction, right? Because this portion is hydrophobic, this portion is hydrophobic, and this portion is again hydrophobic. So they will interact each other, which is called hydrophobic interaction, and they will come to close proximity, right? And then these middle H2O molecules will be dispersed, right? So now initially this entire aliphatic group was covered by H2O molecule, but after that uh, fewer H2O molecules will be covering this amphipathic molecule, right? And then when we will increase the concentration more, when we will add more amphipathic molecule, then there will be almost no water, right? So all hydrophobic groups are sequestered from water. So this, see, all these hydrophobic groups are buried inside, they are not facing water, right? And these water molecules are dispersed outside, so they will form a micelle, right? So that's how it can form micelle. So any doubt in this slide, anyone? If you have doubt, please let me know.
No, sir.
No doubt, right? Okay. So next we will shift to amino acid. Why amino acid? Because amino acids are the building block for protein. So there are different types of amino acids: non-polar amino acids, polar uncharged amino acid, polar positive charge amino acid, polar negative charge amino acid, and aromatic amino acid. So here, so we will first start with the non-polar amino acids. For example, glycine, alanine, proline. So can anyone tell me why this group of molecules are clustered as non-polar amino acids? Can anyone tell me? Why are they non-polar?
Sir,
Yes.
because of hydrophobic chain, side chain.
Because of hydrophobic side chain. Yes, very good. For example, glycine, it has only one molecule. So glycine is actually, I mean, glycine, in which form it will exist, that depends on the pH, right? So that we will discuss. And this alanine, proline, valine, leucine, isoleucine, and methionine, all of them has hydrophobic, hydrophobic, uh,
Side chains.
side chains. Hydrophobic alkyl groups. They are existed as a side chain. So for any amino acid, as you know, that there will be a central carbon, right? In right, so it will make 4 bonds. One with this amino group, second one this carboxylic acid group, third one is with hydrogen, and fourth one is with a side chain, right? And depending on this side chain, we can see different types of and different classes of amino acids. For this case, all of these amino acids has R group, which has hydrophobic alkyl group. So that's why they are not polar, right? But for this case, serine, threonine, cysteine, asparagine, glutamine, right? So all of them has the side chain which is polar. Why polar? Because serine has CH2OH, right? Here OH bond is polar because O is more electronegative and H is electron deficient. So that's why this OH bond is polar, right? Similarly, here also threonine. Threonine has also an OH group, means it is polar. Cysteine. Cysteine has one SH group, and this adding this SH group, sulfur is electronegative and H hydrogen is electron deficient. So that's why this SH bond is polar. So this amino acid is polar, and this asparagine, glutamine, all of them has this electronegative oxygen, right, in this CO bond, and an electron rich nitrogen, right, in this NH2 group. So that's why they are also polar. So they don't have the negative or positive charge in their side chain, but despite of that they are polar. Why? Because they have a polar bond. For example, OH for serine and threonine, SH for cysteine, right? So they have a polar bond. So despite of not having any charge, they are polar because of this polar group. Fourth, so third class is Pranam, you have raised
Sir,
your hand.
yes.
Yeah. Please ask.
Sir, can you go to the slides?
Yeah. Yes.
Sir, here
Tell me.
the aliphatic R groups means
Yes. Yes. Acha, means
aliphatic R groups. Yeah.
R group you know, right? R group.
Yeah, R group I know side chains. Yes, sir.
Side chain, right? So this is the nature of the side chain. So these chains, like for example, the CH, CH3, CH3, then CH2, CH, then 2 CH3, CH3. All of these are aliphatic, right? There are two type of side chain, right? One is aliphatic and one is aromatic.
Aromatic.
Uh,
Yes.
Aromatic will exist when there will be aromaticity, right? So when
Yes, sir.
there will be rotation of the pi electrons, right? So then there will be
Yes.
aromatic. But here you can see there is no such kind of thing, that there is no rotation of the pi electrons. So that's why they are aliphatic.
Sir, then how we'll know that this amino acid that don't have this type of rotation and all?
Yeah, because
How?
of this group. See why? So, for example, if you compare with this and this two, right? They have the
Yeah.
aromatic
Yeah.
group, right? But why? Why they
Yeah.
have the aromatic group? Because they have a benzene ring. For example,
Yeah.
phenylalanine, they have a benzene ring. So you can see this three pi bonds are there,
Yes.
right? So if you remember for your from your school chemistry, that if you have a benzene ring, then and this pi bond in is made up of uh, two electrons, right?
Yes.
Yeah. So in the resonance step, what happens? This bond will be broken, right? So when this bond will be broken, then this side will be negative, this side will be positive. So now the electron is here, right? So now in the next step, this bond will be broken. So now this will be positive and this will be negative. And as this is already positive, so they will make a bond here, right? And now the electron is shifted to here. Okay. Again the same thing,
Yes.
right? Again the same thing. This bond will be broken in this manner. So this will be positive and this will be negative. So they will make a bond here and this position will have a negative charge. So the electron will move from this position to this position to this position, right? So this rotation of pi electron over this ring is defined as one of the
Aromatic.
conditions of aromaticity. Yes. But you can see here there is no pi bonds, right? There is no, there are no pi bond, so that's why
Yes, sir.
there will be no possibility of that kind of pi electron rotation. That's why they are aliphatic and they are aromatic.
Non-aromatic.
Huh.
Non-aromatic.
Yes,
Yeah.
so this is non-aromatic, this is aromatic. Aliphatic or non-aromatic, and this is aromatic.
Okay, sir.
Understood?
Yes.
Okay. Yeah. So we were here, right? Now we will discuss about polar. So these were the polar uncharged amino acids, and these are the polar positively charged R group, right? So for example, lysine, arginine, and histidine, all of them has a side chain which are polar and they have charge over here, here, and here. So they are positively charged R group, and they are negatively charged R group for aspartate and glutamate. So they have the R group which has negative charge, right? And as we already discussed about this aromatic thing, that phenylalanine, tyrosine, and tryptophan, they have, these are the three unique amino acids which has aromatic ring in their side chain, right? So that's why they are having aromatic R group. Okay. So any question if you have, please ask me.
So it's very difficult to remember those all rings and the structure.
Yeah, but you need to really practice those. First, you
Yes,
need
sir.
to understand the concept how these electrons are rotating inside the ring, right? Then it will be easier for you to remember. So please try to practice it. Practice all of this. At least you should have an idea that
Yes.
which uh, atoms are there, right? You should be able to draw.
Yeah, we have to just I have to draw in some matlab revised those all.
Yeah, in your copy, and you can always remember these things by dividing the amino acids in these categories, right? Polar uncharged,
Yeah.
polar positive charge, polar negative charge. Then it will be easier
Yes,
for
sir.
you. Easier for you. Okay, so now we will go to titration of amino acids. So Vikrant, did you have any experience of doing titration in your practical or theory? What is titration? Vikrant, can you hear me? Okay. Pranab?
Yes, sir.
Yeah. So, do you have any idea about the titration?
Sir, to determine concentration of the unknown solution by adding some solution concentration.
And actually, what happens in the titration? What do you do actually? How do you do?
Like,
Hmm. Okay, you can.
sir, basically, titration helps to calculate unknown concentration.
Okay, okay. So in titration, what we do, if we have a acid, then we add base, and if we have a base, then we start adding acid, right? And then we observe the when the solution is becoming neutral, right? As we know that if you add uh, acid to base, then it will become salt and pH will be neutral, right? And the amount of you know the amount of base you have to add in acidic solution will calculate the concentration and pH of the given acidic solution. So Pranav is right. He said that we can calculate the concentration of a solution, right? But I just want to add that we can also calculate the pH of a solution also. Okay, okay, very good. So here we will be studying the amino acid titration, right? So here we are using this term amino acid, right? Why they are acid? Why this chart we have read? Why are they acid? What do you think? What is acid?
So these all are the amino acid that we have to add some. If I will see that if I will add some base to the this acid, what will be happen?
Huh, huh. Yes, correct. But if you see that in each of this molecule, uh, yeah, so in each of the molecules, so they start with this form. Like for example, glycine, it starts with this form, which has a COOH, right? So then when we start adding base to it, for example, KOH or NOH, then it will release this hydrogen, right? And as we know that a molecule can donate its proton, for example here H plus, then if it can donate its proton, then that molecule will be acid, right? So that's why these amino acids are acid. So first we will start with glycine. So here the initial concentration of glycine is there. Then we have started adding the base OH minus, right? So then at the first step what will happen, this acidic hydrogen will be removed. So it will becoming NH2 NHC plus CH2 C double O minus, and as it has one positive and one negative charge, so this is called the deuterionic form of glycine, right? In the next step, this acidic proton will be uh, eliminated, so it will become NH2CH2 C double O minus, right? So this pK1, and this pK1 is the pH where the glycine will exist as equimolar concentration of this form and this form, right? Then it will reach to Pi. At the Pi, what is Pi? Pi is the isoelectric point where the net charge will be 0. So at this pH equal to Pi, right, at this pH equal to Pi, which is very close to 7 here, at that pH the molecule will exist as completely deuterionic form, means total charge is 0 plus minus 1, which is equals to 0. Then it will remove this proton from this group, so now it will become NH2CH2 C double minus. So at the pH equal to pK2, the molecule will exist as equivalent concentration of this form and this form, right? So this is the titration curve of glycine, right? So any doubt here? If you have any doubt, please ask me.
Sir, this pi is equal to 5.97.
Yes.
This so that the next step that CO in COS that bombing that means that they are forming that deuteric ion form.
Yes.
Deuteric ion.
Yeah.
This only means the pi that
Pi is the pH when the molecule will exist completely in
Geometric
fixed
form.
running form. Yes, you are correct. And pKi is the pH when the molecule will exist half of this and half of this. Means equal amount of this and equal amount of this. Okay. So then after you will keep adding base, then this molecule forms will be increased and this molecule form will be decreased. At pi, this molecule forms will be 0 and this molecule forms will be the molecule will exist in only this form. Right? Clear?
At the Yes, sir. At the starting, it was the acid. Then we are
In the
adding
starting, yes,
base.
yes, yes, yes. Very good, very good. In the starting, it was acid, and then that's why I ask you the question that why it is acid. Then see, gradually it will release this proton and right what actual acid does, and it will be turned into this form, right? This form, which is a running form.
Sir, at the last is what
At the last,
it is base NH2CH2 C double O minus.
yeah, yeah. At the last, yes. Now it is base. When it will lose
Okay, sir.
this proton, it will become base, right?
Yes, sir.
Yeah. So for glycine, you can calculate the pi by using this formula pk1 plus pk2 divided by 2. If you use this formula here, pk1 plus pk2 divided by 2, then we will get the pi 5.97. Okay. So now it was easy for the glycine. So now we can go to some complex one, which is glutamate here.
Divided by pi, sir. pk1 plus pk2
Divided by 2.
divided by pi divided by 2.
Yeah, that is equal to pi.
Okay.
Okay, you can check it here. You can take a. Okay, so if you have a phone, then just check it.
Yes.
Is it
2
matching?
point.
And then let me know. Is it matching?